Have you ever wondered how the red planet Mars came to be? Imagine, about 4.6 billion years ago, a swirling cloud of dust and gas started to collapse under its own gravity. This cosmic dance gave birth to our solar system, and among the celestial bodies formed was Mars. A closer look at Mars reveals a fascinating composition. At the heart of Mars lies an iron core, much like our own Earth. This core is surrounded by a silicate mantle, a layer composed of rocks rich in silicon and oxygen. Covering the mantle is Mars's crust, a thin shell of rock that forms the planet's surface. This structure, though similar to Earth, gives Mars its own unique characteristics, painting the planet in shades of red and earning it the moniker of the Red Planet. So, we've seen the birth of Mars, but how does it compare to our home, Earth? If you were to stand on Mars, you'd feel lighter. But why is that? It's all about gravity. Mars is smaller than Earth, so its gravitational pull is weaker. Imagine weighing 100 pounds on Earth. On Mars, you'd only tip the scales at 38 pounds. You'd be a featherweight in no time. But it's not just about weight. Let's talk distance. Mars is further away from the Sun compared to Earth. This greater distance means Mars is colder than our home planet. It's like moving from the sunny beaches of California to the icy tundra of Alaska. The distance from the Sun also affects the length of a Martian day, or a sol, which is a smidgen over 24 hours. So, if you're a night owl, Mars might just be your perfect planet. Mars may be different from Earth, but it wasn't always so alien. Imagine a time when Mars had a thicker atmosphere, even rivers and oceans. Picture a Mars that was once, believe it or not too dissimilar from our own Earth. Yes, you heard that right. Mars, our red neighbor, was once cloaked in a thick, dense atmosphere, much like Earth's, teeming with rivers and possibly even vast oceans. So what happened? Well, over billions of years, Mars underwent a dramatic transformation. Its once thick atmosphere began to thin out, the rivers dried up, the oceans evaporated, and the planet gradually morphed into the barren, desert-like world we're familiar with today. But how did Mars lose most of its atmosphere, you ask? Good question. It all comes down to the planet's core. Unlike Earth, Mars's core is not active, meaning it doesn't have a magnetic field to protect its atmosphere from solar winds. Over time, these high-energy particles from the Sun stripped away Mars's atmosphere bit by bit until only a thin layer remained. And what about today's Martian atmosphere? It's primarily composed of carbon dioxide with traces of nitrogen and argon and is about 100 times thinner than Earth's. This thin atmosphere can't retain heat, leading to frigid temperatures that can plunge as low as minus 195 degrees Fahrenheit at the poles. Mars has changed dramatically over time, but what does its current state tell us? Well, it tells us a story of transformation, of a once potentially habitable world that has become a cold, dry desert. But it also offers us clues about the future of our own planet. From the first flyby by Mariner 4 to the current Mars rovers, humans have been fascinated by the red planet. Over the years, we've sent a fleet of spacecraft to explore and decode the secrets of Mars. In 1965, Mariner 4, NASA's spacecraft, made a successful flyby, taking the first close-up pictures of the Martian surface. 28 years later, the Mars Pathfinder mission landed the Sojourner rover, which became the first to traverse the Martian terrain. Fast forward to the 21st century, and our explorations have become even more sophisticated. The Mars exploration rovers, Spirit and Opportunity, have roamed the Martian surface for years, digging into the soil and analyzing samples. The Mars Reconnaissance Orbiter has been circling Mars since 2006, capturing high-resolution images and data. Today, the Curiosity and Perseverance rovers are our eyes and hands on Mars. Equipped with state-of-the-art instruments, they examine the Martian landscape and climate, searching for signs of water and life. In orbit, the Mars Atmosphere and Volatile Evolution, or MAVEN, studies how Mars lost its atmosphere. These missions are not just about exploration. They also prepare us for the future, for a time when humans may step foot on Mars. Our exploration of Mars has been extensive, but the biggest question remains: could life exist on Mars? Is it possible that Mars, our neighboring planet, could harbor life? This question has intrigued scientists and space enthusiasts for decades and continues to inspire ongoing research and exploration. The possibility of life on Mars revolves around one essential element: water. NASA's Mars Reconnaissance Orbiter detected signatures of hydrated minerals known as perchlorates on the Martian surface. These findings suggest that liquid water flows intermittently on Mars's present-day surface. Further evidence comes from the Curiosity rover, which discovered Gale Crater, an ancient lake that existed 2 to 3 billion years ago. The lake environment would have offered the necessary chemical ingredients and environmental conditions for microbial life, if any existed, to survive. In addition to water, methane is another key pointer. On Earth, 90% of methane in the atmosphere is produced by living organisms. Curiosity rover has detected seasonal fluctuations of methane in the Martian atmosphere, a phenomenon that remains unexplained, but could potentially indicate some form of life. The discovery of certain minerals on Mars also strengthens the case for life. For instance, hematite, a mineral that forms in water, has been found on the planet. This suggests that there might have been enough water in the past, possibly creating a conducive environment for life to evolve. However, the harsh conditions on Mars, such as its thin atmosphere and the intense radiation from the sun, make it difficult for life as we know it to exist. Yet, we must remember that life on Earth is incredibly diverse and adaptable, thriving in the most inhospitable places, from deep-sea vents to Antarctica's dry valleys. Therefore, even if Mars doesn't host life now, it could have in the past. Moreover, it's not beyond the realms of possibility that life in some form could exist in the planet's subsurface or in pockets shielded from radiation. While we may not have definitive proof of life on Mars yet, the search continues, sparking our curiosity and fueling our exploration of the universe.